In September 1944, a British meteor pilot spotted something over the English Channel that his instruments said was moving at over 400 miles per hour at low altitude. He was flying the most advanced Allied fighter in service. He couldn't catch it. The object was a V-1 flying bomb, and the only reason he eventually brought it down was by flying alongside it and flipping it with his wingtip, because his guns jammed and he had no other option. That moment, right there, is the entire thesis of this video, compressed into one image, a machine so far ahead of the doctrine built to stop it, that the human response had to be improvised in real time. Every aircraft on this list did something similar, not to V-1s, to entire generations of aerospace thinking. They arrived before the radar that could track them, before the missiles that could reach them, before the tactics that could counter them, before the materials science that should have made them impossible, and in several cases, before the intelligence assessments that were supposed to know they existed. Here's what ahead of its time actually means in military aviation. It doesn't mean futuristic looking. It doesn't mean fast in a general sense. It means a specific capability gap opened up between what this aircraft could do and what anyone around it, friend or enemy, had any framework to respond to. And in that gap, for however long it lasted, the aircraft was essentially operating in a different war than everyone else. 5 of them. Let's go. Number 1, de Havilland Mosquito. The conventional wisdom about the Second World War British bomber is heavy, slow, defended by gun turrets, acceptable losses. That was the doctrine. That was the procurement philosophy. And then de Havilland built the Mosquito with no turrets, no armor to speak of, a wooden airframe, and the operating assumption that it simply wouldn't need to be shot at, because nothing flying in 1941 could catch it. Seriously. A wooden aircraft, balsa and spruce and birch plywood, bonded with glue that de Havilland's engineers had developed from furniture manufacturing. The Air Ministry thought it was a joke when the concept was proposed. The production order was initially denied. The company built a prototype with private funding. When it flew in November 1940, it was faster than the Spitfire. The operational Mosquito B Mark IV reached 380 miles per hour at altitude, faster than the Luftwaffe's primary interceptors. The Germans, encountering it over occupied Europe, initially reported it as a new American fighter. It wasn't. It was plywood. Here's the part that actually reframes everything. The Mosquito's survivability rate was the best of any RAF bomber in the war. Not because it was armored, because it was fast. The entire philosophy, remove the guns, remove the armor, spend that weight on engines and aerodynamics, was considered reckless in 1939 and proved correct by 1942. The aircraft the Air Ministry didn't want to build flew 28,000 sorties over Europe, with a loss rate so low that RAF Bomber Command eventually used it for the most sensitive precision strikes of the war. Ahead of its time, the doctrine it disproved is still being argued about today. Number 2, SR-71. Blackbird. Look, everything you think you know about the SR-71 is true, and still somehow not enough. Mach 3.2. That's 3,500 kilometers per hour. London to Istanbul in under an hour, while taking reconnaissance photographs with enough resolution to read a newspaper headline from 24,000 meters, while being actively fired at by surface-to-air missiles. And here's the thing. It wasn't just that the SAMs couldn't reach it. They frequently could reach the altitude. The problem was that by the time a launch was detected, computed, and a missile was in the air, The SR-71 had already moved so far downrange that the intercept geometry simply didn't work. The aircraft was its own defense. Speed was the stealth. The Pratt & Whitney J58 engine that made this possible is, I would argue, the single most extraordinary piece of propulsion engineering in aviation history. It operates as a conventional turbojet at lower speeds. And then, above Mach 2.2, it partially bypasses the compressor and transitions to something closer to a ramjet. The same engine changes its operating principle mid-flight, not between flights, mid-flight. The pilot doesn't touch a switch. The thermodynamics just change as the speed increases, and the engine adapts. At cruise speed, the leading edges of the SR-71's titanium airframe reach approximately 316 degrees Celsius. The fuel is used as a heat sink before it reaches the engine. The aircraft is so hot that the fuel running through the airframe structure is actually cooling it. And here's what I cannot stress enough. The airframe was designed with gaps between the titanium panels on the ground because engineers knew it would expand by several centimeters once it reached operating temperature. The SR-71 leaked fuel sitting on the runway. That was intentional. That was the design. It was retired in 1998. Nothing has replaced it. The capability gap it leaves, fast, high, autonomous, survivable reconnaissance, has never been filled by any system currently in the public record. If your brain is still here and hasn't quietly handed in its resignation, hit subscribe, because we go this deep every single week, and we haven't touched the aircraft that NATO spent 15 years and billions of dollars building a response to, based almost entirely on a misunderstanding. Stay. Number 3, MiG-25 Foxbat. In 1971, Israeli Air Force F-4 Phantoms encountered an unidentified aircraft over the Sinai Peninsula. They went to afterburner to intercept. It pulled away from them at what their instruments estimated at Mach 3.2. No radar lock was possible. The aircraft disappeared over the horizon and was gone. The Americans filed what they knew about this contact and combined it with satellite imagery of the aircraft's shape. Enormous twin engines, massive intake area, clearly built for extreme speed. The assessment was, this is the most dangerous interceptor ever built. The kind of aircraft that could chase down anything. The SR-71 would be vulnerable. The response was to accelerate the F-15 Eagle program, specifically designing it to counter a threat that, it would turn out, was substantially different from what anyone had assessed. Because in September 1976, Lieutenant Viktor Belenko of the Soviet Air Forces landed a MiG-25 at Hakodate Airport in Japan and defected. And when American and Japanese engineers took it apart, here's what they found. Vacuum tubes, not transistors. Vacuum tubes, the same technology inside a 1950s television set, in the avionics of a frontline Soviet interceptor. Not because the Soviets were 15 years behind, because vacuum tubes are hardened against electromagnetic pulse, the kind generated by a nuclear weapon, in a way that transistors are not. The aircraft had been designed for a nuclear war at the systems level from the beginning. It was a machine built around a specific threat model that NATO had never correctly identified, and here's what made it fast. Not sophistication, brute force. The MiG-25 had two Tumansky R-15 engines producing an absurd amount of thrust, driving an airframe built from welded steel, not aluminium, not titanium. Steel. It was heavy, it was powerful, and it was fast in a straight line in the specific altitude band it was designed for. The turning performance was, generously, limited. The range was modest. The radar was powerful, but not subtle. But none of that mattered, because the threat it was built to counter. The B-70 Valkyrie nuclear bomber, which was canceled before the MiG-25 entered service, required none of those things. NATO had spent years and accelerated the F-15 program to counter a nuclear interceptor made of steel and vacuum tubes that was never designed to dogfight. The intelligence failure didn't produce a bad outcome. The F-15 is arguably the greatest fighter ever built. But the logic that produced it was based almost entirely on a misreading of what was parked inside those Soviet hangars.
Upper 4, F-117, Nighthawk. Here's the thing about stealth. It's not invisibility. This sounds like a minor technical correction, and it is absolutely not a minor technical correction. The F-117 Nighthawk had a radar cross-section of approximately 0.01 square meters. For comparison, an F-15 Eagle presents a radar cross-section of roughly 25 square meters. The Nighthawk was, on a radar screen, about the size of a large marble. A machine 11 meters tall and 20 meters long, about the size of a suburban house, returning a radar echo smaller than a bird. This was achieved not through one technology, but through an entire philosophy applied simultaneously at every design stage. The faceted angular surfaces, the distinctive flat panel geometry that makes the F-117 look like it was assembled from road signs, were designed to deflect radar energy away from the source at specific angles rather than reflecting it back. Every weapons bay sealed flush when not in use. The exhaust was shaped and cooled to reduce the infrared signature. The surface was coated with radar-absorbing material applied in layers measured in millimeters and maintained obsessively between sorties. A single damage panel could compromise the entire cross-section. And seriously, the F-117 first flew in 1981. The aircraft that would define fifth-generation stealth philosophy for the next 40 years was operational while Ronald Reagan was in his first term. It flew classified operational missions before most of the world knew it existed. The public announcement of its existence came in 1988. It had been flying combat-ready sorties for years before anyone outside a very small circle of classified briefings knew its designation. In Desert Storm, it struck more than 40% of all strategic targets in the opening phase of the air campaign while representing approximately 2.5% of the coalition aircraft. Not because it carried more weapons, because it could go places other aircraft couldn't without being detected, couldn't be targeted while it was there, and was gone before the defenses oriented. It was retired in 2008. The airframes are in storage in Nevada, intact and theoretically reactivatable. Someone, somewhere, kept them whole. For 5, F-22. Raptor. The F-22 Raptor has 186 airframes, that is the entire production run, and it has a combat record of 0 air-to-air losses against 0 air-to-air engagements because no Air Force has yet put an aircraft in the sky willing to engage it directly. This sounds like a limitation. It is actually the most extraordinary operational fact in the history of jet aviation. The F-22 has been in service since 2005. It has operated over Syria, over Iraq, over contested airspace. And in 20 years of operation, no opposing Air Force has initiated an engagement with it. The deterrent effect of an aircraft so capable that engagement seems irrational, that's not a technical specification. That's a strategic outcome. Here's what's inside that outcome. The F-22 supercruises at Mach 182 without afterburner, meaning it crosses the sound barrier and keeps going in sustained flight without the thermal signature that afterburner creates. Its radar cross-section is comparable to the F-117's in the frontal aspect. Its AN/APG-77 ASA radar can track targets while emitting at power levels too low for standard radar warning receivers to reliably detect. The aircraft can see you while being functionally invisible to your sensors. The thrust vectoring nozzles give it post-stall maneuverability, the ability to point the nose at targets that are not in the direction of flight in the energy state where conventional aerodynamics no longer apply. The pilot sits inside a system that fuses every sensor input, radar, infrared search and track, electronic warfare, into a single display that makes the airspace legible in a way no previous generation could achieve. Not faster reflexes, better information. And the human flying it wears a helmet that costs more than most cars, breathing equipment designed for altitudes the body was never intended to reach, in a cockpit that is, and this is not a metaphor, one of the most complex enclosed environments humans have ever operated in. By the way, drop a comment. Which of these 5 jets surprised you the most? And which one do you think actually changed the course of aviation history more than the others? Here's the thread that runs through all 5 of these aircraft. None of them were understood when they first flew. The Mosquito was a furniture company joke. The SR-71 leaked fuel on the runway. The MiG-25 was a nuclear war machine mistaken for a dogfighter. The F-117 was flying operational sorties while the world thought stealth was a concept paper. The F-22 is so capable that engagement with it has apparently been assessed as irrational for 2 decades. Ahead of their time doesn't mean they were futuristic in some vague aesthetic sense. It means there was a specific, measurable gap between what they could do and what anyone around them, including the people who built them, had full frameworks to understand. And in every case, that gap was only really visible in retrospect. Which is the unsettling implication underneath all of this. If these 5 aircraft were not properly understood while they were flying, what's in a hangar right now that we don't have the framework for yet? I genuinely don't know, but that's exactly why there's a next video.